Hello, everyone. On this clip, we like to talk about how to find derivatives using product rule and quotient rule, and also second order derivative. Okay, I pick up two questions from the homework. They're here. Okay, so that's part of your homework. So I picked up some questions, and these are the questions. Okay, I'm gonna circle them. One is number 30, and the other one is number 28. And I think I probably would also do the odd numbers. It doesn't take too much time. Okay, so I try to control the lessons in a shorter time. All right. To find the first order derivative, apply product rule. So we got a product rule, we have learned product rule. So let's apply it. Let's use it. So here's the product rule. Okay. We got the product rule right here in front of us. And we're going to apply it. The first question, we're going to take a derivative. So we're going to see this one as one function, which is the f in the product rule, and the e to the power x as the other g. Sometimes people like to do this on the side or next to it. That's not a problem. We will take a derivative of root x, right? You can write it down this way. The derivative of root x, that's equals to 1 over 2 times square root of x. Because we need to use these anyway, right? The derivative e to the power x. I'm going to find it on the side. Derivative e to the power x is e to the power x. Right? Okay. So when we differentiate the product of the two, we just say f prime of x, or if you like to write it in the other way, no problem. Okay, so f of x. So either one of the form, right, that equals to, I'm going to follow this formula. F, okay, you just have to designate which one is f for you, which one is g for you, okay? So take the first one as f, the second one as g, okay? So I'm not marking it, so I just take it, I'll keep the f, right? Differentiate the g. I can write it this way. And the plus, you keep the e to the power x and differentiate the other one. You can write it this way. You can write it this way. Okay? Or you can also write it, okay, so we see some kind of consistency, right? So if you use the Newton-Leibniz notation, you may like to write it this way. If you use the prime notation, you may like to write this way, right? And also, I mean, this way, okay? Parentheses prime, right? Parentheses prime. Okay, do you have to show this? No, this is optional. I'm just showing this to you because I'm doing the lesson. In the end, I will show you the different versions, okay? 2 major different versions of your work. And then you just plug in. If you do the first version, if you do this version, right? And you try to be consistent with yourself, the derivative e to the power x is e to the power x. So this piece is you're going to have a root x and then multiply e to the power x plus e to the power x. And the derivative of root x is, 1 over 2 times root x. And if you want to reorganize it, why not? Right? Sometimes, conventionally, we like to put it this way. And why? A number of things. When you handwrite it, this is to avoid confusion. When I type it, of course, you don't see such a confusion is possible. Or you can put it over here. So all of these are okay. Okay, so that'll be your answer. If you write the other way, the prime way, right? And of course, you're also going to get the same thing. You get a root x, right? E to the power x. Okay, and plus e to the power x, right? Multiply that. Can we use that, write root x as the power form? Of course. Okay, so either way, so you got your answer. You can express it. So finally, I like to clarify how much work do you need to show? How much work to show, right? If you show it this way, right, you can actually go straight here. If you just show that piece equals to that for a question like this, perfect, no problem. You don't have to show so many lines like I did there. Okay, if you show the prime notation, okay, that's good enough. Okay, so either way, okay, so you don't have to show these small details as you are getting better, okay? Because pretty soon we're going to use derivative to tackle more complex situation. So that's the first order derivative. Remember, that's just the first order derivative. We're going to find second order derivative. First order derivative is found, right? You can use either one. And next, we're going to find second order derivative. So how do we find second order derivative? Two different forms. Okay, I'm going to put this away. If we're using this first form, okay, so next, we're going to find second order derivative. Okay? Obviously, when the first order derivative, second order derivative is a derivative of a first order derivative. So this is the whole of first order derivative. And the derivative of first order derivative is second order derivative. It's also written as in this form, okay, d squared of y dx squared. And of course, we didn't have y introduced here, so we just replace y by f of x. Write it like this. Okay, so please practice these notations. Please practice using these notations. All right, so we got first order derivative written. Now we're taking derivative of the first order derivative in order to get second order derivative. So we have first order derivative. So now the whole of these will be replaced by the first order derivative. Derivative law still apply, okay? Such as the sum, differences, they all apply. we can differentiate this piece and the next piece separately. And so it's just how you want to differentiate it. Okay. So if we want to continue to use our product rule, and I would write it this way. I would write it half. Okay, I'm going to bring this 2 over here. And the x, I'm going to, because it's a denominator, I'm going to write it as x raised to the power of a negative half. Okay. There. So the whole of it now is over 1, and we can omit the 1. So we write it like that. So this will be application of product rule, and this will be another application of product rule. So let's do it. Let's do it. So we're going to differentiate separately. So differentiate that part, okay, in parentheses, and differentiating that part, and a constant is left out this way. And now I can remove the bracket. So the derivative of the sum is the sum of the derivatives, but each one in the sum is a product, is application of product rule. So let's keep going. Let's keep going. Okay. So work on this product rule, e to the power x times root x. Well, our question started with that form. So now we take a derivative of that one more time. So we can just copy this result. Okay, because the question started with that. Now we differentiating this one more time. So I can just copy this piece. That's the same. Right? So that part is the same. So the first part of derivative, this part is done. Finished. Okay? Well, if you want to repeat the process we did earlier, that's no problem. The second part, we have a constant in front of it. And this time we have to do the hard work. So we're going to differentiating that. And differentiating this power is going to be negative half. So you're going to differentiating x raised to the power negative half. And so that's x raised to the power of negative half minus 1, right? Negative half minus 1, right? So we just finished differentiating that power part. E to the power x, we're going to keep it. Remember, we're applying product rule. Okay, so let me make some space for our work. All right. Product rule, right? So here, I'm going to bring up the product rule. So that's just, we leave the half out. You can pause to do your own and then come back to compare notes with me. So we differentiate that part, that's the f. So it doesn't matter. G, so I leave this one out, right? And plus, now I'm not differentiating x to the power of a negative half. I'm differentiating e to the power x. The derivative of e to the power x is e to the power x. Boom. Second order derivative is on the way, right? So this is f prime g, right? F g prime. Okay? I'll call it according to the formula. All right. But this, it will be best if you do it along my side. I know you are, okay? Because otherwise you get lost so easily. Simplify. So negative half minus 1, that's going to be negative 1/3. Negative 1/3. It looks a bit messy. Yes, it is. Okay. And what else can we do? you certainly want to open up the bracket. Okay, so we're gonna take the half and multiply inside. Okay, so take the half, multiply that piece, and multiply this piece is a -1/4. And remove the bracket, plus sign, minus sign together, that makes negative. Okay, and the other one is a plus. Do we need to reduce this even more? I think we can just leave it here as such. Okay. One thing you may want to do is to make the form of expression more consistent. For example, this part, okay, we talk about you either use O power or use O root, right? So this piece is going to be 1 over x times root x, right? And that piece is 1 over root x. 1 over root x, right? So this way it will be all consistently root form. And if you know, usually you stop anywhere here, stop here or here, that'll be fine. But I'm just going to give you a little bit more, because we'll need this technique for chapter 4. We want to write it in a factor form. So for now, it's additional. So at least I want to expose you guys to this. Is that I'm going to factor out all the e to the power x, which I can, right? So e to the power x is factored out. What else can be factored out? Right? I first factored out the e to the power x. So all of these are gone outside. It's gone outside. Whoops. Right? Gone outside. What else can be factored out? The other thing can be factored out is actually, oh wait, these two can be combined. How come I didn't see that? These two can be combined. That's nice, right? We could have combined these two. If we combine these two, we have two of it. Right? We have two of it. So this is gone, and the x and this 2 and 2 will be reduced. Right? That's what we got. This looks cleaner. Right? So we combine these like terms. Guys, this takes a lot of patience. Okay, be patient with ourselves. Okay. The next thing you want to do is, if you want to reduce it, is to find common denominator. We actually do have a common denominator here. Okay, we do have a common denominator here. But in terms of factoring, I think I want to stop here because otherwise it will be too long. You can continue on that journey if you want to improve your algebraic skills. Okay, so that's the first one. First order derivative, second order derivative. So second order derivative found. Okay, this form, or the other one in factored form. Okay, so that's considered done. Let's look at the next one. First order derivative, we have to use power. We have to use a quotient rule here. Quotient rule. So let's bring ourselves the quotient rule right here. Right? That's quotient rule. D squared, which is the denominator squared, differentiating the numerator, which is Let me write it down, a step that's usually considered optional. F prime g subtracting f z prime, right? F is a function on the top. F is f g prime. G prime. Okay? So when you write something like this, you're really quoting the formula, right? F prime g, right? The numerator is f, the denominator is the g. So g squared. This step should be paid a lot of attention. Okay, you don't want to rush through this, and you don't want to make those common mistakes. Excuse me. And then it's the second step you really need to show. Okay, so derivative of x is 1. Oops, what did I do? So this is 1, right? If it is 1, we can omit it. We can omit it. The derivative of x squared, we're going to apply the derivative of subtraction, right? The derivative of difference is the difference of derivative. So this derivative of -1 is 0. So this whole piece is just 2x. Okay? Simplify. Remove the parentheses here. And this is a 2x squared. This kind of reducing that you should carry it out. You should carry it out. Okay, so what do we get? X squared minus 2x squared. So this is going to just be 1 minus -1 minus x squared. Okay? If you like to be a little fancy, actually in the numerator, you can factor it out. You can factor out the negative sign. And the numerator will become x squared, or 1 plus x squared. That's finished. That's finished. All right, so let's find the second order derivative. Second order derivative is a derivative of first order derivative. So we're differentiating the whole of the first order derivative. Right. According to the laws of derivative, I can bring this negative sign outside, so I don't need to worry about that. But it needs to tag along. It needs to tag along with us. And then we're going to apply the quotient rule, right? And of course, in front of that, a big quotient rule, we need to have a negative sign with it. Denominator being squared, that e is being squared. Okay? On the top, right, we're going to differentiate 1 plus x squared first. Numerators being squared, being differentiated first. Multiply the denominator, right? Subtracting, right, the numerator, which is 1 plus x squared. Multiply the derivative of the denominator. So now you match your formula. Let's match the formula, right? Denominator squared, that was the denominator being squared. Numerator being differentiated, right? That's f prime, g, denominator, and f, which is the numerator, 1 plus x squared, and g prime. Right, so you make sure that this step is done correctly before you proceed, because everything else, if you don't do this step correctly, the rest is not going to be right. Okay, so this step is decisive. This piece is 2x, right? How about that? How do we differentiate this piece? Right, this is before chain rule, okay? And of course, the denominator, you can do the power times power, that's going to be 4, right? Power times power, 2 times 2 is 4. So denominator is taken care of, the first term is taken care of. How do we differentiate this part? Before power rule, before chain rule? Well, be patient with ourselves, all right? We're going to FOIL, okay? We're going to FOIL. So I'm going to put this on the side, but I'm going to come back to show it to you, okay? So we're going to do this on the scratch paper, okay? So before we take the derivative, we're going to FOIL this piece, okay? This is a typical of a minus b squared, right? And that equals to a squared minus 2ab plus b squared. You can see this algebraic formula is very, very commonly used. And of course, our a is x squared, right? X squared and then being squared again, so x to the power 4. Subtracting 2ab, 2ab, right? B is -1, so b is 1. And a is x squared plus, b squared, which is 1 squared, 1. So we're basically differentiating that piece. We're differentiating this piece, right? So I don't think we need to do it on the side. We can just take this piece, right? We could have done it here, which is let's do it here. Okay, replace the whole thing by it, right? And write one more step. Be very careful, okay? So the derivative of this piece, okay, is going to be 4x raised to the power 3 subtracting 4x. So derivative of that piece. If you need to do it on the side, right, you do it on the side. So you differentiate, double check, right? Double check, it doesn't hurt, right? So double check, differentiate it, right? The derivative of 4x to the power 4, derivative x to the power 4 is 4 times x raised to the power 3. The derivative of x squared is 2x. 2x times 2 is minus 4x. Derivative 1 is 0. So we got it right. So this piece is your scratch paper. Your reader doesn't need to see it. Your reader does not see it. Okay? And next, we're going to simplify. This is a kind of simplification, right? So major steps. You know how to do this step. You gradually simplify. This is the perfect opportunity for us to demonstrate to improve our algebra. Okay. Excuse me. I'm drinking some tea. Okay. So how are we going to simplify this? The simplest way is to FOIL this, right? Is to FOIL this. Before we FOIL this, okay, I see this part, and I realize I can factor out the 4 times x. I'm going to factor out the 4 times x. Okay. I'm really taking my time. Okay, I'm going to factor out the 4, factor out the x, right? So this is going to be x squared. 4x is out. Oops, 4x. We notice there's x squared minus 1, there's x squared minus 1 squared, and there's x squared minus 1 to the power 4 in the bottom. So we can actually reduce this one. Reduce x squared minus 1, which means that's what I meant. Okay? Well, you factor this out, right? Factor one of the x squared minus 1 out. So this will have 1 left. And the whole of it, and we have x squared. Oops, what am I doing here? I have a x squared minus 1 being factored out. You can see it that way. Or you could just cross out. Okay, so you write it this way. So x squared minus 4 will reduce with the denominators x squared minus 1. So you get here. Okay, and the other way to do it, I'm going to put it that way. I'm going to put it on the side, and of course I will give you options. How do you express it soon? Is that from here, right? From here, x squared minus 1 squared, x squared minus 1, x squared minus 1. So you recognize the factors. Let me change the color, right? Change the color. So this piece, curl. All right, this piece, it doesn't become curl. What's wrong? There. Okay, so this piece, and one of these, x squared minus 1, x squared minus 1, you just simplify that. Okay? And if you cross them out, you also get these. So either you do by factoring, okay? Of course, this is 1, you don't have to write it, right? 1, you don't have to write it. So either cross out, but don't cross out so that we don't see it, right? Or you just factor this out and reduce that way. Either way, right? So we get to this step. We get to this step. And then what? This time we can distribute and simplify. Okay? So 2x times x squared minus 1. So that's that 2x, right? Is multiply x squared and 2x times 1, right? And 4x is going to multiply the 1, 4x is going to times the 1, This is what you can do. And meanwhile, it's just equals to 2 times x raised to the power 3 here, right? And minus 2x over here is going to be minus 4x. And subtracting, this is going to be subtracting, right? Because minus 4x times 1 plus x squared. So this is going to be 4x to the power of 3. Combining like terms, do we have any? Do we have like terms? Yes, we do, right? So these two will make minus 6x. Minus 6x. 2x to the power 3, 4x raised to the power 3, and that's minus 2x raised to the power 3. So this piece is gone, right? So this piece is gone. We got negative, we got negative, we got negative. So if we factored out the negative on the top, if we factored out the negative on the top, right? So this will turn into plus. And of course, you can also factor out 1x, but mainly the two negative sign makes positive. So towards the end, right, negative makes positive. And you can remove this parentheses now. So this is the end. This is the end. You can factor the top, which is not hard, right? Factor out 2x. And now it comes to the point, how do we show work? How much work do we need to show? Okay, how much work we need to show? How much work to show? I would definitely show this piece. You don't have to show this part, okay? But I would show this part, okay? And then you can get straight here, okay? Because you always have scratch paper along the way. You don't want to make it too long. You want to make it, it's make it possible to read, but also not so exceedingly long. Okay, so we got here, right? And I will show this piece. That demonstrate your algebraic skills, right? Here we did the factoring for that part. And then we reduce the x squared minus 1, right? X squared minus 1. And then the distributing part, you can get it straight. You can get it straight here. You can get it straight here. And there. I think this will be acceptable. It's possible to read it mainly, okay? So what I went through, that's a lot of details, and you also see the options of doing it in different ways, okay? But the main thing is we need to have patience, okay? Patience and diligence. All right. Thank you for watching.